All right, so this is the practice worksheet for the retake for Unit 4, Part 1. And the first two problems have to do with graphing a power function. So if my power function, I have an even power here, so any x value with an even exponent, it's going to, the basic shape is going to be parabolic. All right, so we're going to have a u. All right, but we're also going to look at the transformations. So this u is going to be shifted up 3, and it's going to be pointing downward because of the negative. So I'm just going to go up 3. Here's my vertex for my parabolic shaped function, and it's going to be pointing downward. If my exponent is odd, so I have any power of x that is odd, the general form is going to take on the shape of the cubic function or the chair function. And in this case, the chair function is not going to be at the origin. We have a shift 2 units to the right and up 2. So it's like my new center is going to be 2, 2 instead of the origin. So I go over 2, up 2, and if it were just a chair function, it would look like this. But now I'm going through a new center. So it's going to take on this shape, going through this point, which is my origin, new origin. In part 3, we want to graph this function by using the intercepts and just the general information that we know about parabola or about polynomials. We know the intercepts come from the zeros. So I'm going to have a 0 at 0. So when x is 0, I get 0. If x is -3, I'll have a 0, and x is 5. Now if I look at the multiplicity of the 0, this one has an even multiplicity. The multiplicity is 2, and because this is even, we're going to have a bounce at the x-intercept at 0. -3 also has a multiplicity of 2, and we're going to have another bounce. And 5 has a multiplicity of 3, which is odd, and this tells me that the graph will pass through the x-axis at 5. Now for the y-intercept, because I have an x-intercept at 0, I'm going to have a point going through the x-axis at 0, but this point is also the y-intercept, so it's going to pass the y-intercept at 0. So y equals 0 for my y-intercept. Now if this negative x squared was not here, so I'm going to cover that up. To find the y-intercept, I would plug in zeros for x, just like I would for any function to find the y-intercept. So if I didn't have the x squared here, I would have 0 plus 3, that would be 3 squared, which would be 9. And 0 minus 5 is -5. To the third power would be -125. So in this case, my y-intercept would be 9 times -125, and whatever that equaled. All right, so that would be a negative y-intercept with a very large number. All right, the degree of this polynomial, all I need to do is add up my x's. So here I have 2, and I have 2 more here, and then I have 3 over here. So 3 plus 2 is 5, plus 2 is 7. So my degree is 7, and this is odd. So what that tells me is that my end behavior would have arrows pointing in the opposite direction. Now, normally, if this were a positive value, it would be starting low and then coming up and then going up high to the right. But because this is negative, my arrow's going to come down from the left, and it's going to go down to the right. Or actually, it's going to go up to the left and then goes down to the right. Okay, so, and then in between here, we have all those curves and maximums and minimums. Okay, so if I just plot my intercepts, I have one at 0, I have one at -3, and one at 5. And I know from my end behavior that it's going to go up high this way, come down and do whatever, and then it's going to go down this way. So just looking at this, if I do a sign chart real quick, so this would be -3, and I pick values that are in between my intercepts. Like if I pick one over here, like -4. -4, if I plug it into my function, when I square -4, I get a positive number, and then I multiply it by -1, so I get a negative number. So essentially, any number I put in for x squared will become positive, and then will become negative when I multiply it by -1. So this first factor is always going to be negative. If I put in -4 into the middle factor, -4 plus 3 is -1. And if I square it, I get a +1. And that's true also for this middle factor. Anything I have here, whether it's positive or negative, when I square it, it will become positive. And in this last factor, if I put in -4 minus 5, that's -1. So a -1 to the third power is a negative. And when I multiply a negative times a positive times a negative, I'm going to get a negative. So anything to the, I'm going to get a positive. 2 negatives make a positive. So anything to the left of -3 is going to be positive. And we can kind of see that because my arrow is pointing up to the left. Now if I pick another number like 1 between -3 and 0, if I plug in 1 here, remember anything here is going to be negative. And anything here is going to be positive. So this last term, if I pick 1 minus 5 is -4, and a negative to the third power is a negative. So again, this is going to be positive. Between 0 and 5, I'll pick, sorry, this was -1, so I'll pick +1. I calculated with -1, I just didn't write the negative. I pick +1, so this is negative, positive. And then if I plug in 1 here, 1 minus 5 is -4. To the third power is still a negative. So 2 negatives make a positive. So I got a positive here. And then a number bigger than 5, let's choose 6. Negative, positive, and then 6 minus 5 is positive, so positive to a third power is also positive. So in this area, I'm going to have negative values. Anything bigger than 6 is going to be a negative value. All right, so now if I just kind of fill in what I know, I'm going to start with my large negative x values. So I have, coming from this way, I'm going to go down and hit negative 3. Well, what happens at negative 3 is that because the multiplicity is 2, it's going to bounce. So it's going to touch and it's going to come up and it's going to come back down and hit 0. What happens at 0? 0 has an even multiplicity, so it's going to bounce again. And it's going to come back down and it's going to hit 5. And what happens at 5? I have an odd multiplicity, so this is where it passes through. So it's going to come down and it's going to go down far that way. So the only area in this function that is negative are numbers greater than 5. And I can see that in my sign chart. Everything else here is above the x-axis, so it's positive. It's what I have here. So for long division, I'm going to divide by x squared plus 2. And I'm dividing into, and if I check all of my exponents, I have a 4 and I'm missing a 3. So I got to hold that place value of the third power. Let's write that in here. 5x to the 4th plus 0x to the 3rd. And then I have a 2, a 1, and a 0 power. So everything else I'm going to just fill in as I see it. So minus x squared plus x minus 2. So I'm estimating by using the x squared. I'm estimating what it would take to multiply x squared to get 5x to the 4th. Well, my coefficient is 1, so I need to multiply 1 by a 5 to get 5. I have 2 x's and I need 4, so this would be 5x to the 4th. Now I'm going to multiply, kind of like the distributive property, I got to multiply both of these numbers by 5x to the second power, 2 plus 2 is 4. So 5x squared times x squared is 5x to the 4th. And I'm subtracting. 5x squared times 2 would be 10x squared. So that's a positive, and I'm going to line them up so that my x squares are in line together. So now I'm going to subtract. Those cancel. I don't have any x to the 3rd powers, so it's like saying 0 minus 0, no x to the 3rds. And then I have negative 1 minus 10. Negative 1 minus 10 is negative 11x squared. So then I'm going to multiply x squared times what number to get negative 11x squared? Well, this would be negative 11. Negative 11 times 1x squared is negative 11x squared. And by the way, I should have brought down these extra numbers here, so I have plus x and minus 2. When I multiply negative 11 times 2, I get negative 22. So I'm going to put negative 22 underneath the constant area. And now I'm subtracting again. So these cancel. I have 1x minus no x's, so I can just bring this x down. And negative 2 minus negative 22, so that's negative 2 minus negative 22 is 20. And this is my remainder. So I write plus 20 over x squared plus 2. All right, so that's long division. Now we have synthetic division. Okay, so I'm dividing by x plus 3. So in synthetic division, I'm using my 0. And my 0 here is x equals -3. That's my 0. So I'm going to use -3 as the number I'm going to use for the division part. And then I need to put all my coefficients. So let's check to make sure that we have all of the exponents in between between 5 and 3. So I have a 5, a 4, 3, 2, 1, and 0. So I don't need to hold any place values here. So I'll write the coefficients as I see them. 2, 5, -2, +2, -2, and 3. First term comes down. Multiply, I get -6. Add down, I get -1. -3 times -1 is +3. Add down, I get 1. -3 times 1 is -3. Add down, I get -1. -3 times -1 is +3. Add down, I get 1. And -3 times 1 is -3. Add down, I get 0. All right, so my remainder is 0. When I'm dividing an x to the 5th times x, my new leading term is going to be an x to the 4th. So I'm going to take this x to the 5th and drop it down 1 because I divided by an x, so I have one less exponent. My coefficient here is 2. Then I have -1 x to the 3rd. Then I have +1 x squared -1 x plus 1. So this is my answer. All right, so hopefully that is going to help you do much better on the retake.